Welcome back. In lecture 15, we will cover the second part of transportation planning service. The different concepts that would be covered in this lecture are fractional factorial design, which is taken up as a part of conjoint analysis, then design of choice cut using SPSS software, advanced data collection techniques, mobile application based survey and data collection, and finally data collection using application programming interface. So in the last lecture, we have discussed in detail about stated preference and rival preference service, and we have seen that in stated preference service, one of the methods is conjoint analysis, where hypothetical scenarios are presented to the person to choose one of those scenarios as per his choice. And in each of these scenarios, we give a set of attributes with certain levels, and individuals can choose the one which he likes the most. So this is how, suppose for example for mode choice, we have given choices for bus and auto rickshaw. These are the two modes of choice, and we give different attributes for bus, like what is the bus fare, what is the travel time by bus, and similarly we also give attributes for auto rickshaw. And then we can also change the levels of fare, or we can give different variations of fare, different variations of time, and see in which situation a person chooses which mode. And that is how a conjoint analysis is done. And once this choice data is acquired, then we can do a regression model with this data, and where both the relative importance of each attribute and also their preferred levels can be determined. So that means we can determine which are the attributes which are actually playing a role in a person's choice making, and also at increasing the level of one attribute to which at a particular level will lead to a certain change in the probability of mode choice, and that also could be established using these regression models. And this we will cover in detail in later lectures. And in addition to that, we can also use the background information of respondents, for example, the socioeconomic characteristics of respondents, which will also allow us to design products and services for different market segments. That means we can find for different economic groups which plays a bigger role in mode choice, which are the attributes which play a bigger role, or maybe for different genders, which are the attributes which are of more concern. These all could be determined using this kind of analysis. Now, as you can see that there are certain attributes that we need to include in that choice model, and also each of these attributes has got certain levels. For example, fare could be set at 5 rupees, it could be set at 10 rupees, or it could be set at 15 rupees for the same journey. So these are three levels. Or we can do it in form of same as present, or 10% increase, or 20% increase, or it could be 25% increase, or 50% increase, in something like this. Now, as you can see over here, when we consider a full fractional factorial design, which is also called a full profile approach, for example, we have got x is the number of attributes and y is the number of levels. So for example, we have got 3 attributes, and each of these attributes has got 2 levels. Then we can say in a full factorial design, the total number of combinations is y to the power x, or that actually comes to 2 to the power 3. So that is around 8 combinations. So there is 8 ways we can give these different combinations in front of the person whom we are serving, and he can choose out of these combinations which he prefer. Seeing these combinations, he can choose a particular mode as per his preference. Now, this is for attribute where we have all the attributes have got 2 levels. But if I have 3 attributes with 3 levels and 2 attributes with 2 levels each, in that case the full factorial design would be 3 to the power 3 into 2 to the power 2. So that comes to around 108 choice cards, or we can say 108 combinations. So as you can understand, this is very, very difficult for a surveyor to, or rather the researcher to actually decide on what kind of combinations he can present to a person. because if I present a combination of 108 choice cards to one person, then he would be of course overwhelmed. So we can only give him a set of 3 cards or 4 cards or even less than that. So beyond that, a person will become confused. So to limit the number of, so too many combinations actually will increase the complexity of the survey, and also we need to have different sets having different number of choice cards. So it becomes very difficult to design this kind of a system. So it would be better if we have lesser number of combinations that we should test. So one method to do this is to do a fractional factorial design. There are of course many other techniques, but this is the most popular technique to reduce the total number of choice cards by selecting a few treatment combinations instead of running all combinations. So this is called an orthogonal array, which is designed to capture only the main effects. Now, what is main effect? Now, main effect basically means whenever there are variables and there is a dependent variable, so each variable has an effect on the dependent variable. So independent effects of dependent variables of variables on the dependent variables are called the main effects, whereas many variables, when they affect the final choice of a dependent variable, it's called an interaction effect. So it's, as you can understand, because of correlation, if 2-3 variables are playing a role in the final on the dependent variable, in that case it may be difficult to establish which one is having a main effect on that particular variable, or what is the actual contribution of that particular variable. So it is better to investigate where the cases are with only a single variable, or the independent effect of a variable has to be only considered. So that is why in orthogonal design actually that we try to only capture the major effects or some interaction effects, the low level ones. The higher level interactions where there are many variables working on that particular final dependent variable, those combinations are actually avoided. So orthogonality in statistics means uncorrelated. So that is what we are trying to achieve. So while designing experiments, stated preference experiments, we need to make sure that factors are orthogonal, otherwise their effects cannot be estimated separately. So that is what we are trying to do. And it has been found that higher order effects are relatively very low as compared to the main and first order interaction effects, and hence these higher order effects are not omitted, or rather not considered, when we do a fractional factorial design. So when we do a fractional factorial design, as you can understand, for example, if I take a bus and auto rickshaw mode choice, this is the problem, and I want to create choice cards, and I can create choice cards using different softwares. I will come to that. But if I see that there are 1, 2, 3, 4 and 5 attributes, and each attribute has got level 1, level 2 and level 3. So attribute 1, like bus fare, is same as current, 25% increase and 50% increase. Waiting time at bus stop 6 minutes, 10 minutes and 50 minutes and so on. So similarly, auto rickshaw fare, it could be same as current, 25% increase and 50% increase. So we can have different combinations. For example, we can have one card where we say bus fare remains same, but auto rickshaw fare increases by 25%, and crowding level, waiting time at bus stop remains as 6 minutes, crowding level could be 1.5 times of seat capacity, and delay in journey by bus maybe 5 minutes increase. So with this combination, will a person choose a bus or a auto rickshaw? So he has to choose between these two, and he chooses, probably if this is the combination or choice in front of him, he may choose suppose bus, because bus fare is remaining same whereas auto fare is increasing, or it may be different altogether. So that means we have to create many combinations and present it to the person whom we are surveying. So to reduce that, we can do a fractional factorial design, which can help us to reduce the number of these choices. And when we do that using fractional factorial, this kind of technique, then some of these choices are reduced. That means it would be difficult for us to estimate some of the responses, but it still gives us adequate information and of course the total amount of resource, or that means the cost of survey and the time that we will spend in doing this survey, would be reduced. And so that is how we create a fractional factor or a reduced set of choice cards. And we usually do that using software. And one of the most popular softwares used in statistical analysis is SPSS, IBM SPSS. And we will give a demonstration of how to create this choice cards using IBM SPSS statistics software. So just one thing, in addition to creation of this particular choice sets, we also create something called holdout cases. That means we also add a few more combinations than the ones that are finally chosen by this particular software. So we give the software instruction to create some more cases which are usually tested for, we don't take choices of the users for those particular cases, but we test the validity of that particular design using those particular cases. So these are called holdout cases. So here you can see in SPSS software you have to go to data. Once you open the software, then to orthogonal design, and then you have to press generate, and that will bring you to this particular dialog where you will have to fill in the different variable names and their labels. Labels are optional, but you can also fill that. What it means is this factor name bus fare is actually one of the characteristics or one of the criteria based on which you can have multiple levels. So this is one of the attribute that we were talking in the last slide. So here we have created one attribute, and variable names should not contain spaces and should not start with numbers and symbols. So this is a rule in SPSS that you have to follow. So once we have done that, we need to do that with all the other variables, so all the other attributes. So for over here we can see that all the factors and the respective levels are being declared. For example, we have got bus fare and waiting time and so on. And once that is done, we have to create the different values for each of these attributes. For example, for bus fare, we have got 3 values. These are the 3 levels, and each one is given a particular name, like same as current. The next one could be 25% increase, and the one after that could be 50% increase. And so this is the different levels that we are creating. And we can also do a autofill, so that which means that we don't need to give a label. Automatically the values that we take here would be also filled over here. And once this is done, then we need to repeat that for all the different attributes, and then in the next step we need to save this particular file, and we will save it in a folder of your choice. And when we save the file, and that means the final design is created, and later on we can also open this file, and we can see the results of this file. But once you save it, automatically the designs are created. And here you can see that is the file generated over here. So this one, and here you can see the different factors that you have put in, the different levels, attributes and levels, and you can see there are total around 16 cards which have been generated. So this is the final design that has been created. So once we have done that, we can again open this particular file, and now you can see here that all the different attributes are listed over here, all the different levels are given. There are some system defined attributes also that comes in. Then we can select the particular attributes which we want to use, and using that, after the selection, we can get the different cards that can be generated. And as you can see, here are 16 cards that has been generated, and instead of 108 the number of combinations, like for example there were around 3 levels and then there are 5 attributes, so it is around 3 to the power 5 combinations. We have only 16 combinations. Individually each of this card is given, and we can use each of this card for one surveyor, or for one surveyor we can give 2 or 3 cards, and for each card he can give his choice and we can record the choice. So in this way we can also increase the response. That means if we survey 100 persons and if we give 3 cards to each one of them, we can have around 300 samples of data, which we can finally use to do a regression to determine the mode choice model results and all. The modeling part will be taken up in later lectures, but this lecture actually shows you how to create the choice cards using a software like SPSS that we have used over here, and the basic principle behind the fractional factorial design. So next, we will talk about the other advanced data collection techniques in addition to stated preference and conjoint analysis. This kind of service, we can also have completely different ways to also collect transportation data. For example, in today's context, we can develop mobile applications through which we can also collect the data, and GPS tracking is also could be part of mobile application, could be an independent GPS tracking, which could also give us certain kinds of data. Particularly, it could be used for verification of trip data collected from interviews. That means if we can know the GPS location of that particular person on a particular day, we can cross it with the results of the travel diary interview, and we can see if he's telling the right thing or he may have forgotten certain things which we have forgotten. He can again confirm that, or he can recall those things. And then we can also have data which could be collected from different sensors, like there are traffic detectors which are now present in many roads, where like inductive loop detectors, microwave radar detectors, infrared sensors, ultrasonic sensors, acoustic detectors. This actually detect the flow of vehicles, the speed of vehicles, the number of vehicles that are passing through a particular point. So this kind of data could be also collected. So that means instead of counting cars when we are doing a roadside survey, we can also use traffic detectors to actually collect the number of cars passing along a particular road. Similarly, we can also have environmental sensors which can tell us about road conditions, surface temperature, surface moisture, if snow accumulation has happened. Then we can have visibility sensors which can detect fog, smog, dust cloud, heavy rains, and using this we can actually display different messages warning the users of that particular corridor or particular road. Then we can have air quality sensors to monitor pollution levels, and noise sensors to monitor sound levels. And these are the things that we can do. These are the data that we can also collect along with normal traffic data. We have automatic number plate recognition systems. So in many roads nowadays we have this system so that we can detect the vehicle which is going or which is breaking the speed limit, or which is actually during in an intersection it doesn't go along with the signal system, it breaks the signal. So all these things could be detected with automatic number plate recognition technologies. Then there is weigh in motion, where our entire vehicle could be weighed, and we, like for example, freight vehicles could be weighed. They just have to climb on that particular platform and their weight could be measured, and we can see if they have been overloaded or not. So this kind of data could be also collected. Again, you must be aware of social media analytics, we also call that. So where we can do word screenings from social media, and like for example, in case of particularly in case of accidents or a particular event, like the car there is a traffic jam in a particular road or a congestion in a particular road, then automatically people start talking about it in social media. So this could also be tracked, like where the event happened, when it happened, and then if we track the data over a period of time, we can say which are the unsafe locations or the locations prone for accident. And using normal screening of the traffic data, we can also social media data, we can also say that okay, these are the particular things which people are unhappy about for a particular transit system, and we can also suggest improvements for that transit system. So this kind of analysis could be also done. And then finally we have application programming interface. Using this application programming interface, we can also have data collection, which opens up a totally different area of research. For example, different applications, smartphone applications particularly, and are connected with a database at the back, and this application programming interface actually allows us access to this particular database, or gives us access to the big data that we have. That is in today's term, it's very frequently we hear the term big data. So we can do big data analytics, but big data, first we have to access the data, and that could be done through application programming interfaces. So talking about mobile application based service and also a GPS based survey, we did some work in this particular area. And the first GPS-based study was carried out for US Federal Highway Administration in Kentucky in the year 1996. Before that, there was not GPS chips were not there, and after that we had something called a prompted recall survey using smartphones, where we are using a combination of this GPS data along with maybe it could be collected through mobile phones, because nowadays everybody carries a mobile phones along with that which has a GPS chip. Most of the mobile phones do have a GPS chip, and we can collect the location of that particular person, even though there are privacy concerns and other concerns. But in general, if a person agrees, we can also collect the information, and automatically if given permission, the Android operating system or the operating system in the mobile phone can also track the information of that particular person traveling from one point to another. So data is collected through the sensors that are installed in the mobile phone. A mobile phone has got lots of sensors. It has got accelerometer, GPS. Using this, we can determine the location, the speed, and the direction of travel, and so on. And it has got Wi-Fi and GSM communication modules through which it can send the data to a central server in real time. So this is why these systems are becoming very, very important in data collection. And these are all present with individual users. And what we can do is, if we can collect this data with the permission of the user, then the agent or the user can eventually validate this data, adding with other details from his memory, so that the entire accuracy of the data collection process improves. For example, we get some prompts sometimes that, okay, how was your experience in this particular shop? Similarly, we can, after we look at the GPS track of that particular user in a particular day, we can ask him that, okay, why did he spend so much time over here? What was he doing? And accordingly, we can record that information, and that will help us in travel demand modeling. And so particularly in travel diary service, this is where this comes in very, very handy. And this kind of service actually improves the temporal and spatial detail of this particular service. And as we have discussed in earlier lectures, that agent-based modeling, activity-based modeling, this requires very, very detailed level of spatial data and temporal data. And this is the way we can actually integrate data collection, or we can improve data collection for this agent-based models, and using the standard travel diary along with this mobile's GPS-based data collection. This together can help us in getting this micro data that is required for this kind of models. Now, when we develop this kind of mobile applications, particularly for prompted recall surveys like the ones that we discussed, it's a recall survey. That means we're remembering what that person has done, and it's a prompted recall because we are looking at the GPS location and asking that, okay, what did you do over at that point of time? How much time did you spend over there? And all this information. So it's a prompted recall. And to design this kind of survey, we first need to understand the different data needs of the study. That means why we are collecting the data. There is no point in collecting data which is not required. Then what is the subject of the study? That means which are the areas that we are only concerned about. The other things we may not record. And of course, the application development and the different concerns that has to be addressed while we develop the application, mobile application. So this is one of the problems, one of the examples that we can discuss, like for example, trip details of a food delivery agent for analyzing last mile logistic using mobile application. So food delivery, we know that different companies deliver food to a person's for individual's doorstep when he gives the order through his smartphone mobile application. And for that, we can and last mile logistic actually refers to this connectivity at the last mile, and the way this connection is achieved, like how a person is how a particular delivery agent is given a particular order to fulfill, or is he going from one point to another point, how long he is traveling, and how long he's taking to come back. Based on that, the next order could be also given. Or if I know his location, I can give him another order, or he can collect another order which is also has to be delivered over there. So combination of different orders, or carrying 2 orders and then going from one particular location to the next location, all these things are probably could be taken care by in last mile logistics. And this is in this particular research, the simulation of the delivery environment using movement data of existing food delivery agents was actually developed. That means that entire delivery environment for this these agents, that means a particular neighborhood or a particular zone, their movement of all the different food delivery agents was simulated. And this included data on the time and place of the start and end of the first mile. First mile means current location to eatery. That means wherever the person is standing, he gets the order, he goes to the restaurant or that particular place to collect that particular food that needs to be delivered. Then start and end of the last mile. Here the last mile means from eatery to the particular customer location, his movement. And the deadheading mile is basically once he delivers, then he moves to a certain location. It could be a eatery, it could be a eatery where he feels a next order can come, or it could be just a random location where he feels that, okay, that should be my direction of travel based on previous experiences or previous orders and all. So based on that, these are the different components that we need to record. The agent actively delivers food using a two-wheeler during the duration of the study. So he cannot use the app every time, but he still uses the app to look at the location where he's going and so on. And so we need to have minimum interval. So if I develop an app which collects data on his GPS location, or his, he needs to be tracked, we need to take his permission. That means there has to be options for starting the tracking and ending the tracking. It cannot be just going on behind, without his knowledge. And we also need to have minimum intervals. That means he doesn't need to click it every time that or along the way. So the system has to be designed like that. And it has to be designed so that the battery usage is also reduced. That means if I connect with the GPS and continuously send information, then the battery will be drained. So we have to find the balance between accuracy of our information and the number of times we connect with the GPS and so on. So this is one. And then the need to toggle frequently between the primary app and the data collection app should be also eliminated, since the primary app is used frequently. For example, a delivery agent for this kind of food, he will look into the main app where he is supposed to deliver the food and all many times, so that he goes to the right address. But if we put an app which also needs to be used during this particular time, then obviously he has to toggle between the apps. That creates confusion. So that also needs to be reduced. And of course, privacy and confidentiality issues are there. So that means we need to ask him for his permission. We need to, every time he need to confirm he's tracking that particular ride and so on. And because of these issues also, many people don't participate in this kind of service. So this part we really need to take care of, to take the right permissions and on for the people whom we are serving. So in this particular research, the database was built like for each delivery partner. We were storing the data for day 1 and day 2 and so on. We were looking at the order number. It was serial number 1, 2, 3, 4. Then first mile start time, first mile end time, first mile start location, first mile start end location, then start mile start time, and so onwards. So we are recording the entire data, and this is the basic model of the database. And the agents had 2 input options. One is to start the mile and end the mile. That means he need to, whenever his journey starts, he presses start, and whenever his journey ends, he ends the journey. So that means we are taking his permission every time, or he agrees to that recording his particular ride. And the GPS data and time were recorded at certain intervals during this particular period. And at the end of each day, a prompted recall survey was carried out. That means seeing his track, GPS data track, we asked the person that, okay, where did you go, which are the locations. We also matched it with his his memory, that he was saying that he is delivering at this locations and so on. And locations and activities were verified using the GPS and timestamp data for an entire day. So that was done. And here you can see the basic app. This is the registration part for this particular app. and then the app is asking for overlay permission. That means this app will float on the main app. That means you don't need to toggle between the two apps. So this is how we are reducing the need for toggling between the apps. And once that is done, then the person has to press a start mile and end mile just to start recording of the GPS data and the time data for that particular device. So next, in data collection using application programming interfaces, this application programming interface terms, this particularly refers to different routines, protocols and tools which enables two applications to exchange data among each other. For example, we have a application, we have a database for this application, and we want another application to talk to this application. So these are certain programs, certain functions that are written, and there is a certain way, certain architecture is present on way different applications can communicate with each other, because these are two different applications developed by two companies or by different departments of the same company, or it could be a user as well as one company. So that means there has to be a common interface which has to be followed when both these applications talk to each other. And there are certain tools which also helps in the exchange of data. So that is where each program has got their own application programming interface, and using this application programming interface could be there for a database system. That means a database has got certain ways to access it. Operating system, Windows has got a certain APIs, so using which developers can develop their programs and can communicate with Windows operating system. And similarly, computer hardware can have an API, and a web-based system like a mobile app can also have an API. So this application programming interface helps in integrating company systems or app. That means different departments within the company talk with each other. It connects two business partners, two different businesses can connect with each other, or it could be available to a third-party developer. That, for example, Google is the main company, and individual is the third party. That means I personally can develop an app, or I can write some code using which I can access Google's data. So this can be either free, that means the company can give those data free to us, or it could be on a payment basis. That means we have to pay for getting access to that kind of data. And for that there is something called an API key, which actually helps in generating a code which could be used to track which user has come or which application is actually requesting the data. And using that, we can actually some billing services could be also there. That means we can track the number of requests this particular user has sent, and accordingly the company can bill this particular person for that particular amount that he has spent. So once different programs had got this application programming interfaces, we require another software architecture or a set of rules which actually determines how different systems talk with each other. So, and the way of talking. So REST API, we call them RESTful APIs. It's a system architecture which says that how different data could talk with each other. Data could be exchanged between two programs. And there is another interface which is architecture which is called a SOAP architecture. These are the two architectures usually followed. And HTTP and HTTPS protocols, these are the ways the information is sent between these two companies, or these two actually APIs, and to the program and that particular API of that particular another program. So this is how this could be done, and there are different HTTP request methods such as GET, POST, PUT, DELETE and PATCH. So a GET request is used to retrieve information from the given server using a given URL, and a POST request is to send data to the server like customer information or a file upload using HTML forms. So we can either get certain data from that particular server, or we can send the data to a server. Server means that that particular program with whom we are talking, the API is there in a particular server, that is we are accessing that, and we are using that with a URL. And a few of the popular APIs are Google Maps API, YouTube API, Flickr API, Twitter APIs. Twitter has got two APIs. One is the REST API for quote Twitter data access. Using that we can analyze Twitter feeds. That means we can get the data from Twitter the common data, and that we can analyze for what kind of information is there, what people are talking about. We can, as we are discussing in previously, that we can do some data analytics with that. And there is also search API for search and trends data. So these are the two APIs that are utilized and offered by Twitter, which other third parties can also access. Some of the popular Google APIs, we have Maps API, which provides static and dynamic maps, street view imagery, 360-degree view. So in our program or in our data, if I require data about certain street view imageries, certain 360-degree views of certain areas, we can access the Maps API. Also, we can get maps from here. Direction API shows us the way a particular transportation mode can travel between two locations. For example, we can determine the starting and ending point of a trip or the actual route a person follows during a particular trip using this API. So that means we have chances of integrating these systems with existing land use transportation models to do better visualizations, as well as to get certain feedbacks like existing travel time or congestion levels in a particular corridor. This could be integrated in our land use transportation models. So Google API, or like distance metric API, calculates the travel times and distances for destinations. So every trip, starting and end, if I know the start and end point and the starting point of travel, when we are starting the trip, then we can get an estimate of the likely travel time in that particular trip, which is estimated by Google using machine learning and other techniques. But we can directly access the data that actually could be used as a determinant of if a person is going to choose a mode based on those travel times and so on. So that can become an input to our mode choice model, or even our trip assignment, or if a particular route choice model. So then we have Roads API, where we get other metadata of roads, and then we have Place API, where we get information on locations. We have Geocoding API, where addresses could be given a geographic coordinate, or a geographic coordinate, we can find the addresses nearby to that. So all these things could be determined. So using this kind of APIs. Geolocation APIs gives a real-time location of a particular person using cell towers and Wi-Fi nodes. So instead of GPS, we can also go for location search using this particular API. So these are the very, very popular APIs. This could be used by urban planners. In Google, we can start by creating an API key, and before we write the code, which cannot be covered in this particular lecture, which is which could be taken up in some other lecture. But first, the job is to create an API key, where we need to have go to Google Developer Console, where we need to go to navigate to API and services, and then open the credentials panel over here. And in the credentials panel, we can select API key from drop-down menu. And finally, the API key, once it is created, dialog box displays a newly created API key over here. So this is how we can create a Google API, which is open for everybody. But of course, we have to pay some money for accessing Google services beyond a certain number of requests. And this could be integrated in our land use transportation models to have real-time feedback on different travel times and other information that you can use for developing your models. So these are the references you can follow, and IBM SPSS is a software that has been used for the demonstration, and a free version is available, which you can test for a certain number of which you can use for testing this fractional factorial design. So to conclude this particular lecture, fractional factorial design allows easy and efficient conduct of stated preference surveys. Mobile application-based survey is increasingly being used to gather traffic and transportation-related data, where data is collected using the sensors within a mobile phone. Prompted recall surveys using mobile phone increases accuracy and precision of data collected during travel diary surveys, thus enabling development of advanced travel demand models. And finally, APIs allow access to big data, thus opening up a new frontier of urban data analytics. Thank you.